Chapter 11, Section 5, Solving Multi-Step Inequalities. The objective is to learn to solve multi-step inequalities and graph the solutions of an inequality on a number line. Now remember, if both sides of an inequality are multiplied or divided by a negative number, the inequality symbol must be reversed. So if we take a look at this first example, letter A, this inequality, we ultimately want to isolate the variable. And the steps that we did to isolate the variable are listed over here. Remember to clear fractions, simplify and combine like terms, undo addition and subtraction, then multiplication and division, solve for the variable, and check your answer. So on the left hand side we have 3x plus 5. That is greater than 11. We want to isolate the variable x. X is being multiplied and 5 is being added to it. So let's first undo the addition by subtracting 5. I can do that as long as I subtract 5 from the right hand side. These 5's will cancel out, and I'll end up with 3x on the left hand side is greater than, now 11 minus 5 is 6. So 3x is greater than 6. X is still being multiplied by 3, so I want to undo that multiplication. I can use the inverse operation of division and divide by 3, as long as I divide the right hand side by 3. This multiplied by 3 and divided by 3, this will cancel out. On the left hand side I'll be left with x. On the right hand side, let's simplify this. 6 divided by 3 is 2. Now I did not divide by a negative number, so my inequality does not flip. Now on the graph, on the number line, I want to graph this solution. So I'm going to always put 0. I need to show where 2 is located. Above 2, I need an open dot or a closed dot. Let's look at the inequality. Because the inequality is greater than, 2 is not part of the solution. So I'm going to put an open circle above 2. Now I want to point the arrow from this circle either to the right or to the left, but I want it to point at all the solutions to this inequality. So let's put 0 in. For x, is 0 greater than 2? It is not, so I do not want to point the arrow to the left, I want to point it to the right. Let's take a look at example B. In example B we have negative 8x plus 6 plus 4x is greater than or equal to 14. On the left hand side there are some like terms that I need to combine. The negative 8x has a like term of 4x, but we're going to include the plus in front of the 4x. So negative 8x plus 4x. That will come out to be negative 4x. Then I'm going to bring down the rest of the inequality. The plus 6 is greater than or equal to 14. On the left hand side, x is being multiplied by a negative 4 and 6 is being added to it. So I want to undo the addition first. I can do that by subtracting 6 to the left hand side and the right hand side. On the left hand side, these 6's will drop out and I will be left with negative 4x is greater than or equal to 14 minus 6, which is 8. On the left hand side, x is still being multiplied by a negative 4. I can undo that by using the inverse operation of division. So I'm going to divide by a negative 4 to the left hand side, as long as I divide the right hand side by a negative 4. These negative 4's will drop out and I will be left with x on the left hand side. On the right hand side I have 8 divided by negative 4 comes out to be a negative 2. Now I divided both sides of the inequality by a negative number, which means that this inequality symbol needs to be flipped. So the greater than or equal to needs to flip and become less than or equal to. X is less than or equal to negative 2. Now let's graph that solution on the number line. We're going to put in 0. I need to put in a negative 2. Above negative 2, because it is or equal to, I'm going to put a solid circle. Let's put negative 2 into the equation and make sure it works. Negative 2, is that less than or equal to negative 2? It is equal to negative 2, so that does work. Now, from this circle, I want to point to the right or to the left. I want to point to all the solutions for this inequality. So let's test 0. If I put 0 into the inequality, 0 is less than or equal to negative 2. That is not true. So I want to point my arrow to the left. And let's put in a negative 100. Because the arrow is pointing to the left, it's pointing at a negative 100, so I'm going to put that in and see if it works. Negative 100 is less than or equal to negative 2. And that is true. In example C, I've got 2 times y plus 3 minus 4 is greater than or equal to 16. On the left-hand side, you can see that we need to simplify by using the distributive property. So I'm going to take 2 times y, which will come out to be 2y. Then I'm going to have 2 times 3, which will come out to be 6, and I bring down the addition sign. I'm going to bring down the rest of this inequality. Negative 4, or minus 4, is greater than or equal to 16. On the left-hand side, I see 2 like terms. I see plus 6 and minus 4. I'm going to simplify those two, and that'll come out to be a 2. In front of it, I have 2y, and to the right, I have greater than or equal to 16. On the left-hand side, there are no more like terms, so I'm going to start to undo. Y is being multiplied by 2, and 2 is being added to it. So I'm going to undo the addition by subtraction. So I'm going to subtract 2 from each side of the inequality. These 2's will drop out, and on the left-hand side, I'll be left with 2y. And on the on the left-hand side, I'll be left with 2y. On the right-hand side, I'll be left with 14. I just bring down the inequality. Y is still being multiplied by 2. I can undo that multiplication by division, and I'm going to divide by 2, as long as I divide the right-hand side by 2. These 2's will divide out, and on the left-hand side, I'll be left with y. 14 divided by 2 is 7. Now, I did not divide by a negative number, so I just bring down the inequality sign. Y is greater than or equal to 7. Now let's graph that solution on a number line. I'm going to find 0. I'm going to put in 7. Now from 7, I'm going to put in a solid circle because it is or equal to my inequality, which means that 7 is part of the solution. 7 is greater than or equal to 7. Now, from here, I need to point to all the other solutions. If I put in 0, 0 is not greater than or equal to, so I do not want to point it to the left at 0. I want to point the arrow to the right. In example D, I have 4 plus 1/2 times x is less than or equal to negative 2. Now when I look at this inequality, I see a fraction. And our first step in solving inequalities is to clear fractions. So I can clear this fraction by multiplying it by 2. If I multiply one term, I have to multiply every term. So I'm going to multiply 4 times 2, and this negative 2 times 2. 4 times 2 will come out to be 8. In this fraction, the denominator, which is 2, will divide out this 2. Those will divide out, and I will be left with 1x, or simply x. So 4 times 2 is 8, plus x. Let's bring down our inequality sign. Now I have negative 2 2 times, which will come out to be negative 4. On the left-hand side, there are no more like terms that I need to combine on the left-hand side, so I'm going to isolate the variable. 8 is being added to x, so I'm going to subtract 8 from each side. These 8's will drop out, and on the left-hand side I will have x. I'll bring down my inequality sign. Negative 4 minus 8 will come out to be negative 12. I'm going to graph this on the number line. I'm going to find 0, put in the negative 12. Above negative 12, because this is or equal to, I have to put in a closed circle. Now I need to point to all the numbers that will satisfy this inequality. So let's test 0. 0 is less than or equal to negative 12. That's not true, so I do not want to point my arrow to the right. Let's put in a negative 100. Negative 100 is less than or equal to negative 12. That is true. So this would be the graph of the inequality x is less than or equal to negative 12.